Okay, I'm live here with 52 weeks of AWS episode 13. I'm still focused on the solutions architect material. And last week I was able to talk about some networking material, but this week I'm going to get into more networking and talk about connecting networks. And what we'll do is I'll just go ahead and share my screen here to start with. And let's go ahead and get started. Let's go here, connecting. And here we go. Got the material up here, connecting networks. Let's go to a presenter view. So a few things to talk about with connecting network. We're going to cover these topics today. Architectural needs connecting to a site-to-site VPN, also talking about Direct Connect VPCs in AWS with VPC Peering. This happens a lot with maybe a SaaS offering that you're using like Databricks, scaling your VPC network with Transit Gateway, and then also connecting to VPC via supported services. All right, so let's dive into this and get started. Architectural needs. This is always a good place to start as you have some cafe and you want to make a multiple VPC architecture. So how would we do this? Well, let's get through some of the details here. To start with, we would want to talk about site-to-site VPN. And this is a highly available solution that you can use to securely connect your on-prem network and your branch office to your VPC. So I've definitely used this with AWS. It's a pretty cool feature. And what's nice about it is that you can have your own network inside of AWS with, let's say, like a front end website that you're developing. You don't want the public to see it yet. So what you could do is you could set up a VPC with S3 and have your static site hosted there. But then when you use VPN, it opens up that static hosted site and you can do your development to it. So it's really a great workflow if you're doing developer type connections. And there are a couple different ways you can do this. You can do static and dynamic routing. So static would mean that you would have to specify all the routes. Dynamic uses the Border Gateway Protocol, or BGP. And so this is, I would say, probably what you would want to use, the BGP, because you essentially can just access everything on the network by using the VPN. So here's an example of how to connect multiple VPNs. So you would have, let's say, a Los Angeles studio where you're doing filming. When I worked in the film industry, we would do stuff like this, and maybe another network in Chicago, another one in New York. All of those can connect via VPN into the virtual private gateway where it's completely protected. Nobody from the outside world can access it. But you are able to access all the resources on your VPN. So a pretty neat little way to connect, and that everybody's network in these different cities becomes part of the network inside of AWS. Again, that's completely private. So a site-to-site VPN is the way to go. It supports static and dynamic routing, and you can have multiple VPN clients. Okay, let's talk about another one. Remote network with AWS Direct Connect. So Direct Connect, or DX, is pretty interesting service. It allows you to have a dedicated private network connection capable of either 1 or 10 gigabyte of bandwidth. So if you think about it, I mean, 10 gigabytes of bandwidth is quite a lot of traffic. And so you can reduce data transfer costs, you can improve application performance. And what's nice about this is that it can essentially be passively connected to your own data center. So what are some use cases here? Let's say a hybrid environment. So if you wanted to have access to an existing data center equipment, let's say like a specialized database, that would be one use case. Another one would be you need to go back and forth, and maybe you're doing deep learning and you have a bunch of large data sets and you want to operate on those data sets. You could go back and forth and build high performance compute clusters that had both the cloud and your on-prem. Another one that would be interesting would be improved application performance. So if you had systems that could benefit from it, this could be real-time data, video feeds. Another one would be security and compliance. So you have maybe some kind of regulatory environment that requires maybe the cloud for a component of it. You could actually dial in the Direct Connect for this. So here's a good architectural diagram here that shows what's happening. The DX is linking to an internal network over standard fiber optic cable. And then at one end of the cable, you're connected to the router. The other one is connected to a DX router. And you can create this virtual interface. And then you can talk to things like S3 or other resources inside of AWS. And so it really is a pretty nice option for companies that need to integrate both the AWS and all the cloud native features, plus maybe like specialized hardware or even legacy systems inside of their own corporate data center. So another thing you can do with DX is also have a backup VPN connection. And so this is a way of connecting your data center and your VPC by coupling the DX connection for primary connectivity with a lower cost backup VPN connection. And so in this particular scenario, there's two dynamically routed connections, right? So all the traffic can flow through, and one uses DX and the other one uses a VPN. And so you can kind of use the best of both worlds or use it as a backup, depending on what it is you want to do. And this is a good approach for the primary network would have maybe all the traffic going through the DX, but then the backup VPN is there just in case you need it, in case there's some kind of an outage or some kind of an issue. The VPN, though, can only go up to 1.25 gigs, where the Direct Connect can go up to 10. So next up, we have high resiliency for workloads with Direct Connect. You can also build fault-tolerant systems. And so you could have potentially two different corporate data centers, and each of those could have a Direct Connect system there, and then those could go through the VPC. So that would be an interesting scenario as well, because you can kind of leverage your own existing fault tolerance system for multiple data centers. Many places I've worked at, we've had multiple data centers that we managed, but then you could also connect those to the cloud at the same time. So really, in a nutshell, Direct Connect uses open standard 802.1q VLANs. You can access this with any VPC or public AWS in any region except for China, mainland China, and you can implement highly available connectivity between data centers and a VPC. And if you want to do a fault tolerance, highly resilient architecture, you can also do that with multiple data centers. So let's now talk about how to connect VPCs in AWS with VPC peering, which is something that you'll see a lot with like big data systems. Like Databricks is a good example, where you will have maybe a managed service, or Snowflake. I'm guessing they might use something like this, where basically you can transfer things between two different VPCs. And this allows you to isolate some of your workloads, and you might need to transfer between two more VPCs, like development, test, or production. Let's say you have maybe some data in one of the VPCs, like the production VPC, and you want to copy that into maybe a test environment, that this would be a good solution as well. So VPC peering is a one-to-one networking between two VPCs, and it lets you communicate with things in the same network, and you can create a VPC peering connection between your own VPC, or with a VPC in another AWS account, or even with a VPC in a different AWS region. You can establish these relationships between different AWS regions, like inter-region VPC peering is a simple way to do this. And the data is transferred across the inter-region VPC. Inter-region VPC peering enables VPC resources to communicate with each other using the private IP addresses. Good examples of this would be EC2, RDS, Lambda. The traffic is still in the private IP address space, and all the traffic is encrypted. And so you don't have to worry about this being over the public network as well, which is a pretty neat feature. So how would you establish the VPC peering? Well, you would have, in this particular example here, the owner of the VPC sends a request to the owner of the VPC peer, and you say, listen, we want to connect these two things. And then to enable the flow of the traffic, you would have to add a route to one or more of your VPC route tables. And then you also might need to update, let's say, security group rules so that you can send the traffic back and forth to those destinations. Here's a few restrictions to be aware of, is that there's private addresses. It can be established, though, between different AWS accounts. Again, for software as a service products, you'll see this a lot. You can't have overlapping CIDR blocks, and you can only have one peering resource between any two VPCs. So you can't set up VPC peering with like 3 different VPCs, and there is no concept of a transitive peering. For example, like if the production VPC is connected to the development VPC, by default, the VPC peering does not allow the production VPC to connect to the development VPC, right? So you have to explicitly enable that. So consideration for peering multiple VPCs, a few things to consider is only connect VPCs that truly must communicate with each other, and make sure you can scale according to your current and future VPC connectivity needs. So I guess really in a nutshell, don't create a super complex VPC peering setup when you don't need to, right? You're going to introduce problems in the future. So here's an example, VPC peering for a shared resource. In this example, a department in a company peers with a shared service, and this VPC is able to connect to maybe Active Directory, the security scanning tools, monitoring, logging tools, and then the VPC peering enables company applications that are in different VPCs to access the shared services. All right. In a nutshell, VPC peering is one-to-one, and you can establish them across different regions. And there's a few things to be aware of. Like, for example, you can establish a VPC peering between totally different AWS accounts, which is pretty interesting. This might be a good thing to go through on your own, is set up your own VPC peering. And let's go next here to talk about scaling a VPC network with AWS Transit Gateway. So in this example here, we have a network that is across multiple VPCs. So we have something where it has got a lot of stuff going on, customer gateway, VPN connections, all kinds of peering. But what if we want to just make something much simpler, where you have, I guess, more of like a hub and spoke type model? And so how would you do this? Well, we can do this with AWS Transit Gateway. So what is it? It's a service that enables you to connect your VPCs and on-prem networks to just one single gateway. And the advantage of this is that you basically have a central gateway into each VPC on-prem data center or remote office. And so it's a hub and spoke model, and it simplifies your network and reduces the operational costs, because each network can only need to connect to the transit gateway and doesn't need to connect to every other network. And any new VPC is just connected to the transit gateway and then automatically available to every other network. And so you can use this to connect up to 5,000 VPCs in on-prem networks. So this is a very interesting scenario here, where if you did have to do something that was at that level, this would be a great solution. So here's a scenario. You want to connect 3 VPCs. You potentially would want to learn how to deploy AWS Transit Gateway in those with non-overlapping IP addresses. So you would then go through and set up this Transit Gateway hub, and it would be a regional virtual router for traffic between the VPC and the VPN. And then you could set up a Transit Gateway through Amazon VPC dashboard, and you could just take a look at how it works. So the next thing you would do is connect the VPC through Elastic Network Interfaces, or ENIs, and then those would be deployed into the subnets. And then you'd have to go through and make sure that the availability zone that's part of the VPC has an ENI that connects to the VPC to the transit gateway. You can do this by selecting at least one subnet for each of the availability zones for the ENI. And so in this particular example here, what we have is a route table for the VPC3 that has a single destination that is local for VPC3 using that network. So after you go through and you attach the ENI, the next step is to add a route to the VPC table to send the traffic. In this particular example here, we see that the VPC3 route is a traffic destined for that network, which is 10.0.0/8. And this route enables any traffic from the VPC3 going to either VPC 1 or 2, because the CIDR block 10.0.0.0/8 includes the 10x0016 CIDR block, which is used by individual VPCs. So really, it's kind of gluing these things together. And then 4, you would update the transit gateway route table. And then once you do this, the transit gateway is able to send any traffic destined for the network through to the locations that it needs to go to. So really, it then becomes the hub and spoke. You can also use the transit gateway to connect multiple VPCs and also have isolation as well. And so you could prevent your VPCs from directly connecting to each other, and you could make it decide if traffic from one VPC has to be forwarded or not, which is a nice capability. To implement that strategy, you would in the transit gateway route table send all known traffic to the VPC, and then when traffic for any of the VPCs in the 10.0.0.0/8 network is sent from VPC3 to the transit gateway, you would then have the transit gateway forward the traffic to the VPN as shown right here on the slide. And this transit gateway will not send the traffic to any other VPCs because there's no routes, right? So you have total control over how to route the traffic once you have them hooked into the transit gateway. You could send them to all, or you could isolate the traffic. You can also have multiple transit gateways for specific types of workflows. And so maybe a second one will direct inbound traffic from the VPC to one of the corresponding VPCs attached to the transit gateway. Okay, so that's good to know about. And so this would be just kind of a hypothetical scenario here, where if you have 5 VPCs that you want to connect to the AWS Transit Gateway, what would you do? Well, each route would add connectivity to the VPC route tables, and the routes would also be needed to be set up so that you would be able to make these things talk to each other. So I guess the hypothetical situation is, what would you need to do to make these scenarios work? And so in this particular example here, you can see that the route tables are listed. 10.1.0.016 would go to VPC ATT 1XXX and so on. All right, so that's really the AWS Transit Gateway. I think we can talk about connecting your VPC to supported services next. So VPC endpoints, which I mentioned earlier, I've used with S3, are really cool because they enable you to privately connect to a VPC to use a service, and you can enable traffic between your VPC and other services without leaving the Amazon network. And it doesn't require internet gateway, VPN, network address, etc. And they're horizontally scaled, redundant, and highly available. So what are these examples? So we have interface endpoint. This is a elastic network interface with a private IP address. And so this would be an entry point for traffic. And an example would be this private link concept. Examples would be CloudWatch, EC2 API, Elastic Load Balancer. The second one is a gateway endpoint. And this is a target route for your route table. And this would be something that would work with S3 and DynamoDB. And what's nice about this is there's no data processing or charge. You're just billed for each hour that your VPC endpoint remains provisioned inside. And how would you set this up? Here's an example of an interface endpoint. You would first, find the service you want to use. Let's say Kinesis. You would choose the VPC where you want to create an interface endpoint. You then choose the subnet, and then you can actually, if you want to, enable private domain system for the endpoint. And that is a nice little touch, is that in some cases, there's a concept of a split horizon DNS. And this is a kind of way, goes back into the old days, but with split horizon DNS, what happens is there could be two different routes. Like if you come in from the public, you go to one route. If you come in from the private location, you go to another route. And so you could create this whole private world with private DNS names. And then finally, you would specify the security groups to be associated with your network address. So what would be an example? Well, here's one where we have an interface endpoint, and this endpoint has DNS host names that are generated, and the services, like maybe a marketplace service. We also have a private DNS option here enabled. The hosted zone has a record, let's say, for example, and it resolves to a private IP address. And this enables the application to make requests to the service using DNS instead of like a endpoint specific DNS hostname, which can be annoying, right? If you have DNS, you can always assure you don't have to change code or do something like that. So that could be a great scenario for having a full automated, infrastructure as code. And then in this example here, there's a interface endpoint for Kinesis data streams, and the private DNS for the interface has not been enabled. And instances in each subnet can send requests to the Kinesis data stream here. So a nice example here of, potentially a private workflow that you could set up with VPC endpoints. Here's an example of private DNS for the endpoint has been enabled, and this allows the subnet to use either the default DNS host name or an endpoint specified DNS host name to send requests to Kinesis to stream the data. So in a nutshell, a VPC endpoint allows you to create private networks, which in many scenarios could really work out well, right? Because you don't need to have it exposed to the internet. And maybe this is just an internal type scenario. There's two types of VPC endpoints: interface endpoints and gateway endpoints. So really to wrap things up, we talked about on-prem network to AWS cloud, how to connect VPCs, connecting VPCs in AWS cloud by using VPC peering, and then also how to scale VPCs in the AWS cloud, and also how to describe VPCs to support your services. So in a nutshell here, I think next week I will we covered today the connecting. I'm going to cover securing user access and application access next week. So thank you for showing up today. I'm going to maybe wrap things up and just talk a little bit about some of the things that are interesting about what we covered and what I've done in the real world. I think the VPC endpoints are very interesting, like again, with things like AWS S3, because of the ability to essentially use it to do private development, of, let's say, statically hosted websites. The VPN scenario is also a really nice scenario to have very high security. You don't want to be exposing your resources to the public. And there's many scenarios if you're working in a global workplace. I mean, really, at this point, pretty much everybody works from home. You would want to have all the people, the software engineers in your organization, use a VPN connection to connect inside. And then once you're inside the VPN connection, you would be able to actually go through and use the resources like you're physically on the network. So really a great strategy for people using these kinds of scenarios. The other thing that we talked about was these direct connect scenario. And I think that's actually a very good scenario as well, where if you are doing, let's say, deep learning or, machine learning or, you have some kind of like managed, big data system, you may already have an investment, but you still want to use AWS. Using this direct connect solution is a great scenario because you could get this really fast bandwidth connection between AWS and your own physical data center. So it's, I think some of these topics sound a little bit abstract, but in the real world, actually, they're very, very useful to be able to use these kinds of resources. And it is worth studying how to use those services. And I would say probably VPN and VPC are some of the most approachable services in terms of things you can play with very quickly. And I would encourage you to play around with those. So again, I'll see you next week where I talk about securing the users and applications.